So today I'm going to be talking about OOP, Object-Oriented Programming. My name is Alexander. I work for Stack Builders now for almost 3 years, and I'm just setting up the timer. And it was a really difficult flight for me. So before coming here, I thought about making something more practical, because I gave this talk last year at Uruco, and today I'm going to be presenting more code and stuff that you can actually go to your companies and your projects and actually apply it. Okay? So in order to give you these new ideas, I want to start talking about perspective. This guy, Alan Kay, he is the guy who invented OOP. OOP stands for Object-Oriented Programming. And once he said that point of view is worth 80 IQ points. And when I first heard it, it didn't quite make sense to me. But after researching it, I actually realized the meaning of this code, and I started thinking differently about lots of different things. So basically, let's say you have 6 units, 6 things, 6 horses, for example, and you want to sell those horses. If you were living in the ancient times, you'd probably represent it with Roman numerals, right? However, if you need to multiply this to get the prices for all the horses and stuff, you have to be really smart, really smart. Nowadays, though, we just use number 6 like we all know it, and every kid can actually multiply. So reality itself didn't change at all. You still have the 6 horses. But what changed is how we see reality, how we approach it, our perspective, how we abstract it. I love this. I think this is a great example. You see 2 tabletops, and it looks like the one on the left is smaller than the one on the right. But I'm going to show you something. Like the size of this red rectangle, it's not changed. And I'm going to go back, and you can see that it's really weird, right? And actually, I showed you something. I showed you the true reality, I'd say, but your brain continues thinking that they have different sizes. So that's a trap that our brain has for us, which makes it really difficult for us to actually change our opinions. And this is pretty scary if you think about it, because all we have is our sensors, our eyes, and ears. So with that in mind, what is OP? What is actually OO, right? So I want to start with this by Alan Kay. OOP to me means only messaging, local retention, and protection and hiding of state. I'm going to be focusing more today on messaging and local protection, but this is going to be interesting to talk about OOP in the sense that it's about messages. It's not about objects. So, for example, when he invented this term, there was no OOP language. There was no small talk at that time. So he was developing his Dynabook, which is kind of the iPad from the 70s. And he thought about this idea, like, I have a computer, and then I talk to the CPU, and I talk to storage inside of this computer. What if each part of this computer was actually a subcomputer? What if the CPU was a computer itself, encapsulated, and so I could send a message to it? What if the storage was a computer? What if the memory was a computer? And all of this inside of a computer. And so you'd have a computer with lots of subcomputers and so on. In the end, you'd have an architecture such as this. A computer, imagine all of these are like, we have here 5 computers with subcomputers, and they would just send messages between them. And they would send messages between the subcomputers as well. But no computer would be able to access any subcomputer in another machine. So, in my experience, people are usually afraid of having this kind of isolation, this kind of separating things like this, and mostly because of complexity. We were talking yesterday about during lunch, and we were talking, and someone said, well, doesn't it make it more difficult if we separate stuff? Difficult to debug, to reason about? And that's precisely what I'm going to talk today to you. The main reason, in my opinion, for people to not isolate things is fear of complexity. And in my opinion, there are 2 reasons for that. 2 reasons why, when we separate things, things get more complex. The first one is simply disorganization. So you have your big object, and then everyone says, hey, you should refactor this into many objects, right? And then you do it because everyone says so. And then you have many small objects collaborating with each other. And in the beginning, it's all rainbows and unicorns. Everything is wonderful. But then the client never stops asking you for more features, and then suddenly you have something like this. And it's so complex, and then you just hate OP, right? And you just hate having done this separation of concerns. And then it's not beautiful anymore. So the second problem, in my opinion, is simply procedural code. I'm going to show you one example. Let's say, for example, our client wants us to download projects from Pivotal Tracker. Pivotal Tracker, for those who don't know it, it's an application for managing projects. And basically, you have an organization, and inside of this organization, you have a project. And inside of it, you have stories and members. Stories are like tasks, for those who don't know this. So usually people start with a service, and then they call some class there, organizations, import, and then they take that, the returned value, and import the projects, and then they iterate over their projects and download their members, and do the same for stories. That's usually how people approach this kind of problems. But then your client comes to you and say, hey, I also want to download projects from GitHub. And this is just the beginning of the end. It seems so innocent to do something like this, but it's actually pretty bad. And then suddenly you have a method with more than 100 lines of code. And this is actually a real code that I copied from a project from 2 years ago. And also, by doing that, by using that service, in that way, you just flatten the domain. So for new developers, when they're going to read the code, they're going to understand the domain as if it was like this, instead of projects inside of organizations and so on. However, I wonder how people actually build really huge softwares and deal with complexity and things simply work. One example is Curiosity, the Mars rover. Curiosity has 2.5 million lines of code. It was written in C. And wait for it, it's completely OOP. And you might wonder, what? Right? Yeah, I'm going to show you this. And this is actually pretty interesting, and I hope it makes you think. So basically, Mars rover, the Curiosity, has lots of parts. And these parts never, ever access any other's memory references. They all communicate via simple messages. Every part is a subsystem in itself. It's similar to those computers I just showed you. And so they have these components, like you can see some examples there, and each one acts as if it was a virtual machine on its own. And when they have to send messages to one another, they have something called a message queue. And what happens, it's when component 1 sends a message, it sends a command, it doesn't wait for any return value, ever. The only situation where the system actually waits for something, it's when it's receiving a message, when it needs a value from someone else. So the system never, ever stops working. If an arm from the Curiosity stops working, the rest of the system doesn't care about it. It's as if I create a user in memory and I'm going to storage this in database. Why does your Ruby program should care if the database is working or not? It's a database that's responsible for that. You should just send, hey database, just save it. I don't care what you need to do that. There are no mutexes, no transactional memory, complete isolation between modules. And that's exactly how Alan Kay initially thought about OO. It was similar, the thought was similar to having cells, human cells, when they send messages to one another, messages like chemicals. And what I want to stress out is that OOP is not about the objects, as you can see. OOP is about the messages. Because objects define what the system is, and messages define what the system does. And your client doesn't care about what your system is. So the actual value of your software is in the messages. So the Terminator was likely built with OOP as well in the future, with 70s technology and concepts. So NASA basically rewrote Erlang, because that's exactly how Erlang works. And you know what Joe Armstrong said about Erlang? Erlang might be the only object-oriented language. That's the true meaning of OO. So, in my opinion, developers usually have this, they love so much types here, types there, and they just see programs as a bunch of classes, and these classes are just calling methods in other classes. But classes are just a blueprint of your project. You should really care about the objects. And if you think about the object's point of view, if I am an object, I don't care who you are, I'm just going to send you a message. and I expect you to understand it. So I don't care who you are. This is what happens because people love classes so much that when they get into a language that has objects but doesn't have classes, they just hate it because they don't understand, because they so focus on classes, right? So, going back to the initial problem, complexity. If we had two objects, and we could define complexity as simply the interaction between them, we could say that we have a complexity equals 1. You're going to say that if we add one object, our complexity grows to 3. What happens if we add 3 more objects? It goes to 15. I know we don't do such things like every object is talking to every object, but I just want to show the extreme of this kind of architecture when you don't think about what you're doing. And I just put that image of a troll there because, in my opinion, complexity is just that. It's just trolling us all the time. Every line of code we write, complexity is chasing us. So how can we stop complexity? How can we stop wasting time? Because complexity is just that. And if we were talking about time, how can we actually stop wasting money? So I want to start with this quote. The key to scalability lies in how messaging is actually done. The key to abstraction and compactness lies in the felicitous combination of design and mathematics. Alan Kay. So I'm going to present you one solution, and it's called the Constructor Law. Basically, the Constructor Law is a law in nature. It's the only known law that guides design in nature. So whenever nature has to flow something from one place to another, anything, it's going to use this law. And basically, the shape which is used by nature is this shape, the shape of a tree. Everywhere, nature is going to use this. Snowflakes, lightnings, riverbanks, lungs, even cities which have architectures that are made by man. So, if we have this architecture which is on one string, and we apply that constructor law to our architecture, we end up with something like this. Pretty simple, huh? So we actually added one object, as you can see, but our complexity just decreased to 8. So if you compare the two architectures, you're going to see that if you don't put some thought into it, the complexity is just to grow, it's just going to skyrocket. Can you see it, like the red one, the green one? So, for example, if we go back to our computers example, you're going to see that if we can separate concerns and have those modules with the objects that belong into them, and they send messages just to the entry points, the complexity of our system is going to be a lot lower compared to something like this, which people usually do. You have a wrapper around a web service, and it has a client, and it has an XML builder, and then you do some stuff with the connection class, you call some credentials, etc. And suddenly, every object is talking to every object. This leads to decreased complexity, simpler code, lower cognitive load, and less wasted money. So let's go back to our example. This is the previous class, the example I gave before. And I want to just mention that in so-called OOP languages, we borrow the ideas from the original OOP concept. Because in Ruby, we're not really doing things like yearlang. But for example, if we could apply that constructor law here, we would have, instead of a service, we would have, let's say, an organizations class. And it will import your organizations. Can you read it? Is it readable? And then it's going to call the projects class. And the projects class is going to have the same architecture, but it's going to call the members and stories. So from the outside, you never care about members and stories, right? So from the outside, you'd only talk to the organizations class. But then you may ask me, like, how do we do about this? So let's see how our pivotal tracker client looks like. The client is the one that's injected via the initializer. It would probably look like this. We would call an URL, and in this case, I'm just mapping to return something that's not a hash that I can actually work with. But how would GitHub's client be like? We would probably have an organizations method, just like Pivotal Tracker. We would probably have a projects method. We would probably have a members method. What about stories? Well, you only care if an object understands a given message, right? So in this case, it just returns an array. So I can ask you, like, what are your stories? And you're like, well, I don't have any story. So when sending messages to objects, you don't care what the object is. You only care about the messages it understands. It leads to flexible code, less changes, and also doesn't violate the open-close principle. If we need to add new services, we don't need to care about changing the organizations and projects and members classes. So what about debugging? As I mentioned, we were talking during lunch about how hard it is to debug something that's divided like this. And let's go back to our example. Let's say we have 3 computers. And the problem, and there's a bug there. And we don't know what it is. All I had to do is apply binary search, right? Like we isolate it in 50% or approximate. And we try to check which side has the bug. And in this case, let's say we simply isolated this part. So we know that this computer has the bug, the one on the right. So all we have to do, given that you consider this gray area as a computer in itself, all you have to do is put some instruments there to check where the bug is. So I want to encourage you to write great code and not be afraid of trying to isolate your pieces of code in manageable chunks. I was talking to a friend of mine there that's working in a project, and his controller has controller code, email code, tests, all inside of the controller. It even has rescue jobs, all inside one file, all inside the controller itself. And then when you want to run this controller test, you run like controller name.test. I mean, I know it's an extreme, but it actually exists. And I usually find, usually the problem is not that people don't know how to isolate things. Most of the cases is because they don't know how to use their editors. Most of the time, they don't know how to use ctags, for example, or Control-P or Command-T. So I would say embrace OO, because if the guys at NASA are really doing it, there's some chance that it actually is going to work for you. And I just want to put this quote here by Alan Kay when he was asked by the languages that you can use OP in, and he said Smalltalk and Lisp. So OO is not about the language. Ruby tries to get some concepts from OP and applying the language so you can express your code like that. But original OP was not about code itself. It was about the architecture of your system, about how to represent your domain. So if you want to fight complexity, just give it a try. Thank you.